This is Saxon Algebra 1, lesson 93. This is dividing polynomials. Now, in order to get into polynomials, we need to talk about, first of all, what is a polynomial? Well, we already know that a monomial, or starting with the prefix mono, means one, bi meaning two, so two monomials, trinomials three. Well, the catch-all term for anything more than one is poly, and that's for many. So we have polynomials. Now, we already know that when we take a polynomial and we say, like this one here, and I say 3a over x plus 2b over x plus 5c over x minus d over x, that in order to add up fractions, I have to have a common denominator. And when I do so, I'll end up saying this is the same as this, right? 3a plus 2b plus 5c minus d over x. Now, that means that because these are equal, I can go either direction with them. And that's going to be key for us understanding why this works. Look at the example 93.1. They asked us to divide this polynomial, this happens to be a trinomial, 8x cubed plus 12x plus 4x divided by 4x. Now remember, there's more than one way to write divided by, so I write the divided by like this, and I realize that every one of these terms happen to have something in common. But before we jump ahead of ourselves here, we're going to split these into three separate fractions. Now, just like when I can take these 4 and make them into 1 because they have a common denominator, I can take the 3 and separate them. So I don't make up a 4x. They're already all being divided by 4x. I'm just putting it in its place. So when I say 8x cubed over 4x, 12x squared over 4x, and 4x over 4x, well, that reduces, right? 8 over 4 is 2. X cubed over x, 1 is x. These reduce, and these reduce. And I'm given this answer here, and this is correct. Although there's got to be an easier way than rewriting the whole thing and separating it out on every individual piece and dividing it. And that easier way is right here, and we're going to factor the numerator and the denominator first. What's the biggest number that comes out of all three of these? Well, it happens to be a 4x. When I do so, I'm left with 2x squared plus 3x plus 1 in parentheses. Now I can cancel my 4x's, and I simplify, and guess what? I'm back to my original answer. So this is a little quicker. Now, for those of you who are really quick with the mental math, you would realize that all I'm doing is taking a 4x out of every one of these, and you could probably do this in your head. 8x cubed divided by the 4x, 12x divided by the 4x, and 4x divided by the 4x, and I get my answer. Okay? And that works every time as well. Look at example 2. This is where it gets more exciting, because no longer am I dividing by a monomial, I'm dividing by a binomial. And there it is. So if I rewrote it in the fractional form like we're used to seeing, I look at this and say, well, I can't cancel the x's because I've got all these pluses and minuses in here. I can't get rid of this 6 and this 9 with this 3 because there's not one here to cancel out. So there's nothing that can factor out of these that is a greatest common factor, although it is factorable. If I recognize that -6, half of that is 3, squared is 9, I would recognize this as a perfect square trinomial, right? X minus 3, x minus 3. Well, once I do so, I can cancel my x minus 3's, and I'm left with an x minus 3. And that works out nicely. But not always is that very easy to do. So let's move on to one that's a little bit more exciting, and this is polynomial division. Now, this is a new concept for a lot of people. This right here, this is just simplification and no problem. This over here, this stretches the mind a little bit for some people. So stay with me as we do a little refresher on what division is, first of all. If I said long division, I had a problem like this, and I said 128 divided by 2. Well, most of you can do that in your head, but bear with me while we do it manually, as if you were back in 3rd grade, right? And you were doing that long division for the first time, and you're like, okay, so what do I do here? I say, what's the biggest number that goes into 1? How many times can 2 go into 1? And it can't. So I jumped and I say, what about 12? Yeah, I know, 6. So I put a 6 up here, and I say 6 times 2 is 12, and then I subtract it. Now, I put the parentheses in there for a reason, but you would learn it without the parentheses because it was a single term. So you say minus 12. And you say 12 minus 12, that's 0. And you say, well, okay, this is the remainder of this was nothing. So how many times does 2 go into 0? And you say, well, none. So I bring down that 8, right? And I look at it and say, well, how many times does 2 go into 8? And you say 4. And so you say 4 times 2 is 8. And I left the parentheses off on this one. This was reminding you how it worked. And then I did, whatever was left here was 0. If this didn't, you would have written it with an R and up there for remainder. Or you could have written it as a fraction up here, right? That's long division in a nutshell. Well, can I use that same idea with a polynomial? And the answer is yes, and here's how. So look at example 3. And we're going to go through this step by step. And I've been talking fast up to this point because this is all review. I'm going to slow down for you for just a moment here. If I look at this and I say I'm dividing this trinomial by that binomial, I realize that I have a problem. First of all, I'm going to change the order around. I'm going to move the 3x squared into the front, the 25x in the middle, and the 8 in the end. And then I have x minus 8 still in order. So this is great, but if I write this as a division problem, so there's 3x squared minus 25x plus 8, and I'm going to be dividing out of it the x minus 8. Now, I can't do this in my head like I would this one. So I'm going to do this by using the same method as I did with the long division. So I look at it and say, what times x would give me a 3x squared? What times x would give me a 3x squared? Well, a 3 would help, and an x, because 3x, right? So I put a 3x up here. Then I multiply this out and say 3x times x. And I'm going to show you with fingers here, so you can say 3x times x is 3x squared. But I have this 8 hanging in here. So there's negative 8. So 3x times negative 8 is negative 24. And at that point, all I have is this. I throw the parentheses on it and subtract. Now, freeze where you're at here and go back to this. If I threw parentheses and subtract, the reason why I have to pay attention to the parentheses is because this negative is going to change. And watch carefully as I do this. 3x squared minus 3x squared is 0. That's what we did here, right? 12 minus 12 was 0. Then I go to this one and say negative 25 minus a negative 24. Now, I remember from way back in 7th grade, and they said when you take away a negative is a positive. So I say negative 25 plus 24, and that gives me a negative 1x. And then I look at this and say, well, I have a problem because I need 2 terms. So I bring down my 8, and I have this. Now, at this point, I'm looking and saying, well, what times x would give me a negative x, or negative 1x? Well, negative 1. So I put negative 1 times x, that gives me a negative 1x. A negative 1 times a negative 8 is a positive 8, right? And so that works out. And I put that in there. I put my parentheses on it, and I subtract. Negative 1 minus a negative 1. So negative 1 plus 1 is 0. 8 minus 8 is 0. And this works out nicely. It happens to work. And if I go ahead and plug this back in and say x minus 8 times 3x minus 1, I would say x times x, 3x squared. X times negative 1, right, negative 1x. Negative 8 times a negative 3, negative 24x. Negative 8 times a negative 1 is a positive 8. Combine my like terms, you get a negative 25x in the middle. So 3x squared minus 25x plus 8, and that's what I started with. This method looks confusing, but as long as I do these steps, I put it all in order, put some parentheses on it when I'm subtracting, and I remember that when I multiply this one by this, I have to multiply the whole thing in order, not just the first part. Now, let's make it a little more exciting. I skipped example 4. We're going to go right to example 5 because it's going to have both in it. The first thing that you're going to notice when you look at example 5 is they're not in the correct order, which was like 3. So let's start with that. Here it is, not in the correct order. So I rewrite it in the correct order. Now, there's a key here. Notice that I have a degree of 3. There is no squared. It goes from a cubed to a single term. But I need a squared term. Well, can I add 0 to a number without changing it? Well, the answer is of course, because that's the identity for addition, right? So I can add 0 without changing it. So if I add a 0x squared, how much have I changed this problem by? Well, none. So I'm going to go ahead and put that in order here. I'm going to say 3x squared plus 0x squared minus 2x plus 5. It goes in descending order. I need to have every x power represented. 3, 2, 1, none. And that's what I did up here. It just happened to be 2, 1, none. So because of that, I have a 0 placeholder in there. Okay? There's my 0 placeholder. And you'll see how this is going to come in handy. The next is I put up my number I'm dividing by, but I made it x minus 3 instead of negative x plus 3. That makes life a little easier. Then I look at it and say, what times x would give me 3x cubed? Well, 3x squared would. So I multiply 3x squared times x. That gives me a 3x cubed. 3x squared times a negative 3 is a negative x cubed. This is why the 0, 1 is so important. Some books will just move it over and leave it as an empty. That's fine. But in my head, it's easier for me to take away 0 minus a negative, which would be a positive 9x squared. I bring the negative 2x down. Then I look at it and say, what times x will give me a 9x squared? Well, 9x would give me that. So I put a 9x up here. That gives me my 9x squared, right? And then I go ahead and say my 9x times a negative 3, which is a negative 27. And I put my parentheses on it. But I have a problem because now I'm going to say 9x squared minus 9x, that's 0. But negative 2x minus a negative 27. So negative 2x plus 27, and that gives me a 25x. Okay, good enough. I bring the 5 down, right? And then I say, well, what times x would give me 25x? Well, 25 would. So 25 times x, 25x. 25 times negative 3, negative 75. Slap those parentheses on, put my negative out front, right? That's what we do every time. 25 minus 25 is 0. 5 minus a negative 75. Well, it's already a negative, so it becomes 5 plus 75, which is 80. This is what's new on examples 4 and 5. This has a remainder. So I'm going to slip this 80 right at the top and just put it over x minus 3 as a remainder. The other way of writing that would be just like what we talked about up here, where you put a little r and a period and remainder 80. The only reason why I like this one better is this allows me to divide that out of everything and see that it works. Now, a couple of little pieces that you can take from this. Long division is not difficult, it's just time consuming. That's the first thing. Secondly, I have to use parentheses when I subtract or I'll make a mistake with my negatives. A negative negative is a positive. Okay, so I have to use those parentheses appropriately. The third thing I want to point out here is that when you start doing these, you'll recognize these are another way of factoring. If you wanted to know, does this binomial go into that trinomial, let's try it. And long division will allow you to divide it out. If I take the answer and multiply it by what I divided out of it, I would get back to my original equation. And that's how I know that it works. So as you go through these and as you work on them, keep in mind that I could use long division even with a monomial, but it's really not necessary because I can just divide it into all the terms. And long division in numbers works the same as long division in polynomials.